Hi everyone, my name is Park Poomchin Pritiwong from Texas A&M University. Today I'm going to present my work, The Service Worker Hiding in Your Browser, the next web attack target. This is a joint work with Raj Rathan, Guo Liang Yang, Yang Yong Zhang, and my advisor Guo Fei Gu. Recently, you may have heard of the term Progressive Web App or PWA from Technology News. PWA is essentially a website that can also be installed and used just like a native mobile app. The key difference between PWA and native apps are that PWA can be installed just by visiting the website, and the PWA code is running inside a web browser as HTML and JavaScript instead of native languages like Java or Objective-C. And because they are essentially a website acting like an application, we also refer to them interchangeably as Appified Web. A prime example of Appified Web is Twitter, which is one of the earlier pioneers. Additionally, several big companies are also joining the appification, such as Reddit, OneDrive, and many others. For a website to be appified, the most crucial element is the service worker. Generally, a web interface directly interacts with the user and web server. With the introduction of service worker, the website can now work offline just like a native app. A service worker will sit in between the client and server, intercepting requests and response between them. This way, the service worker can receive a request and return a cached response when the network is offline. Note that service workers are running as a part of a web browser as well. Therefore, the security of Appified Web is technically the same as traditional websites. Another feature that a service worker can enable is real-time push notification. The service worker can be reactivated when it receives a push message to display it to the user. This includes when the web browser interface is closed, because web browsers generally have background process running even when the user closes the browser window. To use a service worker, a website can register it through the navigator.serviceworker.register API. This function accepts a path to the service worker file, which is written in JavaScript. Because service workers run asynchronously in an event-based manner, inside the service worker, the website can add several web listeners. For example, the fetch event allows network traffic manipulation and interception. The push event is dispatched upon receiving a push message. Although a service worker enables many useful features for web developers, it consequently attracts attackers due to its capabilities. Several studies have explored how service workers can be used to run malicious background tasks in the victim's client for profit, such as mining cryptocurrency or turning the client into botnet. Nonetheless, these attacks need to assume that the victim visits the malicious website frequently enough, or they will receive a lot of push messages, raising suspicion from the victim, making this approach not as practical. In this work, we want to explore a more practical approach where instead of attackers hosting malicious websites to install malicious service worker, we assume attackers are targeting benign websites. Therefore, we assume the presence of a cross-site scripting attacker and no network attackers. All scripts in the service worker are benign. The goals of attackers are to leverage communication channels between the main web page, which we also refer to as the document context, and the service worker to escalate the initial cross-site scripting attack. To summarize, our contributions are threefold. First, we analyze the communication channels of service worker and uncover security flaws in two channels, IndexedDB and push notification. Second, we demonstrate how the flaws are leveraged in real-world scenarios. Third, we design and conduct a measurement study of the flaws in the wild. We found 5 websites are vulnerable to the service worker hijacking through the IndexedDB, and approximately 1.75 million users per month are potentially exposed to location tracking through push hijacking. For the first attack channel, IndexedDB, we first consider the local storage for websites. There are 3 types of storage: local store, session store, and IndexedDB. The first 2 are not available to the service worker. Nonetheless, existing work shows that they can be used to launch persistent DOM cross-site scripting attack. But little is known regarding the IndexedDB that is also accessible in service worker. Therefore, we investigate IndexedDB usage in real websites and found that some websites are using IndexedDB in a risky manner inside the service worker. In this example, we show a code snippet from the website that we found. The code is generalized and the identifier is removed. First, the code opens an IndexedDB and retrieves an entry called data.config.url. Then, it checks whether the URL matches with its origin before importing the file inside the service worker. However, because the IndexedDB entry can be edited by attackers in the document context, attackers can specify attacker.com as the URL to import and execute the malicious file inside the service worker. This can lead to serious consequences, as the compromised service workers also have the capability to manipulate the network request and response, acting like a persistent man-in-the-middle attacker. Or, it can send push messages in the name of the benign website for launching more targeted phishing attacks. By executing malicious scripts inside the service worker, attackers can potentially obtain these capabilities themselves. Generally, websites will employ mechanisms to prevent attackers from doing so, and the attackers will need to bypass such security checks. In this particular example, using attacker.com/.example.com will not pass the test. However, if attackers encode the dot to %2e, it will pass the check. More importantly, the import scripts API will correctly decode %2e back to dot. This will allow attackers to bypass the security check and import malicious scripts inside the service worker to compromise it. For the second attack, we found that attackers can leverage push subscription to track user locations. Normally, you may have seen several websites asking to show push notifications. By allowing this permission, the website essentially subscribes users to push notifications. However, we found that there is an uprising trend to provide location trigger push notifications among Appified websites. These websites will request for location permission in addition to the push permission. Then, it will track user locations and send them messages based on the area users are residing. These information are also available inside the web portal of the push provider. In this example, we use OneSignal as a case study. But unlike the IndexedDB attack channel, where the problem lies in the implementation of each website's service worker, the problem of push hijacking is due to the protocol design, and it is not tied to the implementation of one signal. The same attack will work even using the primitive push API without any third-party library, but it will require attackers to implement the backend by themselves. This may not be as practical in a larger scale. In any case, OneSignal's subscription API are generic and similar to other third-party libraries and the primitive push APIs. To subscribe the user, the website will need to provide a kind of ID. For OneSignal, it uses App ID, but for primitive API, it uses Application Server Key. Nonetheless, they are conceptually the same. What we found as problems are that unsubscribing can be done easily, and there is no check regarding the subscription ID. Anyone can use unsubscribe and resubscribe using any IDs. This includes attackers. When attackers resubscribe the user using attacker's ID, they can also access the location information of the victim. However, it is possible that the malicious script injected as part of the cross-site scripting attack will not be presented when the victim visits the website later, and the attacker's subscription will be eventually replaced by the legitimate website. So, how can attackers persistently hijack the push subscription? To this end, there are two key observations. First, a website can have multiple service workers associated with different paths. Second, a website can have multiple push subscriptions associated with different service workers. And it is possible that for a web page to register for service workers in a different path. Therefore, attackers can potentially subscribe the user through a different page in a different path that will not call the legitimate subscription to replace the attacker's subscription. One thing to note is that attackers cannot simply register a service worker from a different domain. This will break the same origin policy. Therefore, we have to hijack the push subscription this way by reusing the legitimate service worker file. We conduct a measurement study on the two communication channels. First, we utilize an existing dataset which includes 7,060 Appified websites. We revisit these websites to reconfirm the correctness and collect the IndexedDB and push subscription usage information. For the 3,813 websites with IndexedDB usage, we further perform 10 analyses on them based on the tool provided by Melcher et al. We extend their tool to include IndexedDB as a taint source and sink. The tool reports 40 tainted flows that reaches sensitive sinks that we will further check. For the 1,172 websites with push subscriptions, we perform static analysis to group them based on the libraries. We mark 5 most popular libraries for further testing. Then, we check the 7,060 websites using Open Bug Bounty, a public platform for reporting website vulnerabilities. We found 934 websites have unpatched cross-site scripting vulnerabilities. And if we included patched websites, there are 2,739 websites. This shows our assumptions that there are cross-site scripting attackers are practical. We further confirm the 40 websites reported by the taint tracking tool. We use Chrome DevTools to inspect these websites and confirm 5 websites are vulnerable. Most importantly, one of the websites also contains unpatched cross-site scripting vulnerability, which can also allow attacker to compromise the service worker through the combination of this cross-site scripting and our IndexedDB attack. To evaluate the false negative rate, we randomly picked 60 websites in total from 2 groups of websites. The first 30 websites are from the 3,247 websites that our crawler reports as having no IndexedDB usage. The another 30 websites come from the 3,773 websites that the taint tracking tool reports as having no sensitive flows. This requires us approximately 15 human hours. In the end, we did not find any false negative among these websites. Among the push libraries, there are top 5 libraries that we further evaluate. The criteria for choosing these libraries are the popularity and that they are offering a free tier membership, which attackers can easily utilize to track user locations through their web portals. In total, there are 993 websites utilizing these libraries. Among these websites, there are 200 websites with an unpatched cross-site scripting vulnerability. We randomly pick 40 websites for manual investigation regarding the location permission. Because legitimate websites would often wait for users to engage more before offering further features like the location trigger notification, we have to manually analyze them. In summary, there are 14 out of 40 websites, or 35% with location access. According to SimilarWeb, these 200 websites combined have approximately 1 billion visitors per month, and according to OneSignal, 10% of visitors would subscribe, with 5% interacting with the notification. We assume that interacting with the notification can be a good indication that users may have also allowed location permission. Therefore, we approximate the number of potential victims to be 1.75 million users per month. To mitigate against the IndexedDB attack channel, we suggest proper sanitization at the IndexedDB load and at the sensitive sinks such as eval. As mentioned that while websites use IndexedDB in a risky manner, they often check the loaded entry. It is very important that robust check is employed instead of weak regular expression check. The code shown here is an example of another website that also consumes input inside a sensitive sink, but perform proper check. Another improvement to prevent IndexedDB attack is for web browsers to provide dedicated private storage space. Another improvement to prevent IndexedDB attack is for web browsers to provide dedicated private storage space that can only be used inside the service worker, in addition to the original shared IndexedDB. We implement this storage space based on existing IndexedDB in Chromium and evaluate the overhead. The overhead is shown in this table. Similarly, to mitigate against push hijacking attack, we propose browsers to provide an allowed list that websites can specify which IDs are allowed to subscribe users. We implement this approach in Chromium by having a checks and extra manifest entry for allowed IDs. The overhead is also shown in the table. Based on our study, we lastly discussed 3 observations. First, we theorized that the reason websites use IndexedDB to import scripts is because the service worker does not have access to cookie. So, they cannot initialize the service worker tailored to each unique visitor. However, unlike cookie that has much more protection mechanisms, such as HTTP-only flag, IndexedDB are shared across execution contexts within the same origin. So, they are not safe against cross-site scripting attackers when it is used in place of the cookie. Second, we found many websites disregard vulnerability reports. This may be because websites believe that there is nothing to be stolen from their websites. For example, the websites may not have login feature. However, such kind of websites can still be leveraged as shown in our push hijacking attack. Third, we find that many websites are using push notifications abusively. For example, sending clear phishing messages, aggressive advertisement, or multiple messages in a short period of time. This is in line with recent Chrome change to block websites' notification permission as default instead of ask as default. Because such websites are banned, it is possible that attackers may divert to using benign websites as shown in our push hijacking attack instead. All vulnerable websites have been reported, and we hope that the finding in this work will be helpful for web and browser developers to prevent attacks against service workers in the future. If anyone has any question, feel free to let me know. Thank you.